of prestigious Youngest Scientist Award for its contribution in the computing technologies for Earth observation and remote sensing data exploitation. Good morning, everyone. So I will hand over the session to Dr. Raghavendra sir. Over to you, sir.
Yes, good morning all. There is some echo is coming. All participants can mute your mics. There is a noise is coming. The participant can mute their mics. Okay, now it's fine. So I hope my screen is visible to everyone. Right? Okay.
Yes, sir.
So let's see.
This conference will now be recorded.
This is my. Right. So this now we are trying to. Today we are understanding about some of the programming aspects of cloud computing. So to understand these programming aspects of cloud computing, we'll be using one of the academic institutions tool to write the cloud programming environments and develop this kind of a PaaS platform as a service models for some of the applications that one is planning to host it onto the any of the clouds. So when I say like any of the clouds, it could be private cloud, public cloud, or any of the other clouds like a hybrid clouds also. So we'll be discussing about more on the introduction about the clouds and the type of clouds, and followed by the public clouds, and followed by we'll be discussing about the Aneka PaaS cloud, where the PaaS stands for the platform as a service, and we'll be understanding about the Aneka setup. Then followed by some of the programming aspects. How do we write a program, and how do we deploy it onto the cloud, and then this cloud is going to be Aneka cloud. So how this deployment is being done. And after that, how do we execute some of the programs? Okay. So this is my this is what my agenda. So till this public clouds and Aneka PaaS cloud, I'll be explaining you. And after this, one of the there is another resource person from the academic institution, and Professor Radha, she'll be taking care of the Aneka setup and the followed by example programs. So after this, so this is basically divided into two parts. So first is till setting up the Aneka, understanding about till Aneka PaaS cloud, and followed by the setup and program executions, which will be handled by Professor Radha. Okay, so this is what we are trying to see it in the today's class. So as you are all aware of, okay, I hope my next slide is visible. So as you are all aware, the cloud is in fact has become like a de facto computing infrastructure. So when I say like a de facto, now without cloud, there is no any of the applications being used. And what we say, whether it could be the AI machine learning applications, or it could be the IoT based applications, or it could be any of the autonomous systems, or it could be the mobile applications. So whatever we see as of now, so the entire thing is goes like a cloud infrastructure. So most of these public clouds has become now as a everywhere existing, and the industries and also even the research communities who are trying to use this computing infrastructure. So they're also moving to the cloud-based infrastructure. So when I say like a cloud-based infrastructure, this infrastructure is serviced as a services, or maybe delivered as a services. So when I say like a delivered as a services, so these computing infrastructure, you put it a request on demand, and this request will be delivered on demand, and the kind of a uses that you do, the kind of a resource that you use. So based on that, the payment has been done. Okay, so the model is morely becomes like a service kind of a model, so that the upfront investment and upfront cost of putting up all these services will drastically reduce. Okay, so this is one of the major phenomena that we see when we moved from the traditional computing infrastructure to the cloud-based computing infrastructure. Okay, so when we see here, basically one of the things which we need to understand here is about the transformation of a model, right? So in fact, when this cloud computing has been started over a time period of maybe I can say 7 years ago down the line, so that time we used to give a lot of understanding about the cloud and what kind of how it looks like, and what is the use of these kind of cloud computing, cloud infrastructures. Now, if you see, this is now everywhere it is existing, right? So that's what we say, that it is like the computing is everywhere. So this, as the computing is everywhere now, so then we need to quickly adapt to this new computing environment and start working on that, right? So based on that, I don't give you the overall the in-depth of the clouds and how these things are done. So that is not required. So we now understanding that everybody has some understanding about the cloud computing, and they already studied or they heard about the technologies, or they started using the clouds in some or other. So I quickly jump into the some of the programming aspects by showing you some of the public clouds. Okay. So now if we see this kind of the cloud computing, we generally call it utility computing model, right? So the utility computing is something where the computing is derived or delivered as an utility, like the way we used the utilities like water, gas, electricity, and telephone. Like a water, there is a water distribution network, and followed by the current. Also, there is a power distribution network, and for similarly for other kind of utility models, which the way we get it and use them and pay for them. So similarly, we also used one model of computing, which is called the cloud computing. Okay, so if you see this, in fact, the cloud, we call it a transformation of an internet into an usable model. So the internet, the way it is represented is like a cloud symbol. So when this cloud computing is coming up, so then there is a nomenclature, one name has to be given. So the researchers had some opinion of thinking that the internet is represented as a cloud. So let's make this as a cloud computing model. Okay, so it's basically a transformation of an internet into an usable model, and that's what we call this as a cloud computing model. Okay, and if you see, in fact, this cloud computing is not a new thing which has come. It is been there since 1970s. Okay, and if you see the John McCarthy, he is basically the computing pioneer in the artificial intelligence during those days, and he was also part of the computer networks during the time. He said in the 1960s itself, the computation may sometime be delivered or organized as a fifth utility, right? So that means once the idea of doing it is like the ARPANET project, in fact, which is initiated as a networking project to connect the computing infrastructure into the network. So these networks, when they've been seen as a 1960s and 70s early, so it was thought like they're still in the nation stage. They're starting up the stage, right? So then they said that one day they grow, then probably they can be delivered as the utility. Okay, so that means even this was the statement made by two computing pioneers during those days, which is Leonard and our computing pioneer is John McCarthy, right? So now if we see this, the entire thing is the network, which is going to be a backbone for most of the computing resources to be delivered. Now these computing resources, which has come up over a time period, and where the network has become more like the rigid now, more like a deliverable kind of a thing. So now this computer networks has grown a lot. Now they become more like a robust and also for redundant, and also without any failure that have been happening. And now use these computing resources on top of a computer network as a backbone network, so that they can be delivered as a services. Right? So this is what been happened when you do this kind of a transformation of an internet into the usable computing model. Right? So that's what we call like. So if you see the cloud, it is in fact is it is like a transformation of a use of some of the resources into another use of resources, and making them usable to the every community of the people, so that they can be quickly delivered and start using them. That's what we come like the transmission of internet into the usable model, which is called a cloud computing model. Okay, this is what I was explaining, like using these different types of utilities, like the way we use the telephone, where there's a telephone distribution network, and for a gas there is a distribution network, where the most of the cities, if you see, they don't use this kind of a gas cylinders coming from the delivered from the the people. They have this kind of a setup which is being done in their localities, and there is a pipeline which will go from to the distribution network of the houses, and they start using it, and the units they record it, and the way you pay the electricity, you pay it for the similarly for the this gas products as well, right? So like a gas user. Similarly, there is electricity and the water. Like the way we use this like water, electricity, gas, and telephone, can we also use this another utility which is called a network, or maybe I say that a computing resources of network, then it becomes like a cloud computing model. Okay, so that means the computing resources are delivered as and when they're required, is what we call as a cloud computing model. Fine. So now when we see about the definition, and also most of the researchers, they keep on asking like, how do we define this kind of a cloud computing, and also find how do we make them all these things available to that. So if you see here, the old idea of doing it is like delivering the applications over the internet. Right now, recently when you see about when you come to the cloud, they say that everything as a service. Now the thing is, and when they provided as a services, obviously for a service there is a charge which is being done, right? Like for example, if you see many services, people provide the services and they say that you charge it, even starting from it could be the Ola, Uber, or Amazon, or basically when we buy some equipment, or maybe the Jepto or maybe Zomato, anything, right? So when they do the services, and because they do the services, and they also take some kind of some money because of the service which they're doing it, right? So similarly here also, the cloud computing, when you talk about this, the infrastructure is provided as services to you. That's why this model is called a pay-as-go computing model. So cloud computing, we say like a pay-as-go computing model, where to deliver these kind of infrastructure, platform, and applications as services over the internet, right? So and whenever these services are there is some kind of a service level agreements, right? We call it an SLAs. So these SLAs are between the providers and consumers, and meeting these quality of service kind of parameters. So one could able to provide these kind of services over the networks as the backbone things to get these services, right? So that's what we generally call like it is IaaS. We generally call like the bottom layer of the thing. We call it infrastructure services, where this infrastructure like a computing, storage, network, and other computing elements are made as a services and given to you depending on the request. And the platform as services is basically the software development kits and the software APIs and the kind of a programming languages which will be given as for writing the program so that it get executed on the infrastructure. And the applications are the end user applications, where one can design these applications and provide them as the usable applications to the end user. Okay, so this are these kind of three models which will go. Like one is the IaaS model, the PaaS model, and the SaaS model. Okay, so there are many competitors in the world who are providing these kind of a cloud computing models, and everybody has their own way of looking in the cloud infrastructures, right? Like for example, if you see the infrastructure services, the Amazon provides this web as an infrastructure service like AWS services, like Amazon Web Services. So you can use AWS, and these AWS services will give you the computing resources which can be used over internet by placing a request, and you can be getting the machine that you wanted. Okay, and similarly you also have this Azure, which is provided by Microsoft. Like this, there are so many players in the world where they're able to provide you the kind of infrastructure, so that upfront you need not to do any investment. Depending on your application scale, you can go for asking for those number of resources. And coming to the platform services, these are all provided like an SDK. Like for instance, if you see, if I want to use this kind of machine learning services coming from Amazon, what I can do is there is a platform services like APIs provided to you. You can use those APIs and write applications using those APIs, and it executes on the infrastructure services coming from Amazon. Okay, so that is also for the other cloud providers also. So that's what the platform model, where the SDKs are provided to you, and this Aneka platform can be configured on any of these infrastructure services of your own public cloud or private cloud or hybrid cloud. And once this Aneka is configured on those infrastructure, so there is an SDKs or the APIs are provided for you to write a program. So one can design the application services or the applications which can be provided to the end user, and using this Aneka PaaS, which actually executes on the infrastructure services coming from any of these public cloud providers. Okay, that's what in nutshell when we talk about the various kinds of the applications and the layers architecture, and also the kinds of the things which people will use for the cloud things, right? This talks about the different types of clouds where we try to understand. If you see in the world as of now, there are three types of clouds which people try to offer. One is the public cloud, which is offered through the internet. Private cloud, where it is offered within your own premises. It's not connected to the internet. And there is a hybrid cloud. So this hybrid cloud, in fact, talks about the federation of the private and public cloud. So usually the requirement of hybrid cloud is you are using the private cloud, and as and when the demands, you may have to use the resources coming from public cloud. So then when you make this kind of federation, this becomes like private and public, which becomes like a hybrid cloud. Like for instance, let's say I'm using my own computing resources and I have a storage which I'm trying to use, but later point of time, I say that my storage is not enough for me to archive it. Okay, so for archival, I want to use this public cloud storages, so that whenever any old data, which can I send it to the public cloud, and whenever there is a requirement, again I can fetch it. Okay, so this like archival services I can go for using for a public cloud infrastructure like Amazon S3 or any other storage services. Okay, so in that case it becomes like private cloud and public cloud for the federation part. Fine. Now when we see this, most of the public infrastructure providers, So there are many things when we try to see, like there is Amazon Web Services, which generally call like AWS services, and there is many other providers like Microsoft Azure, Windows Azure, then followed by Azure Services platforms, and there are so many relational databases also provided other things, and there is other cloud providers as well. They also provide like cloud management platforms, which generally call like a right skill, as another cloud service provider. Okay. So if you see this, what they do is they provide this SDK, the software development kit for virtual machine provisioning. Then there is a storage provision, and there is a compute pool creation, consolidation of the servers, the hardware infrastructure, security, and followed by the dynamic resource provisioning. Right? So these are the major, we can say, like the features which we offered as a part of cloud applications usage, and also for the infrastructure usage in the cloud. Now coming to the, I hope probably this last starting from Monday to Friday, we could have been had many sessions of understanding about the cloud and also the different applications which they provide, other kind of infrastructure which have been offered, right? But as being today is the last date, so last day for the FDP program, so I'm not going to tell you more about again all those things what you studied. It's only for you to just brief overview of what is giving types on clouds and other things. Then we'll be concentrating more on one of the academic institution tool today, which is called as an Aneka, to write the PaaS platforms and service models, so that one you can execute and write programs and do that. Okay, that's what we'll be trying with today in the today's session. Coming to the getting to the kind of the programming models, right? So there are basically, we can say that the programming models are divided into three major models in the cloud perspective when you see. So that's one is called high performance computing model, and which is used for reducing the time of any program running on a system. So if you take a single task, and for a single task, how much of effort that I can put up using the computing resources and also for other kind of models, so that the time of the single task will get reduced as much as possible, right? That becomes like a high performance, which we generally call it HPC kind of a model. Now there is another model which we call it like a HTC model, which is a high throughput computing model, where the group of jobs being addressed to reduce the time. Okay, like for example, let's say if I have some 100 jobs to be executed, I want to say that these 100 jobs to be executed within an hour of a time, within 1 hour. So then what kind of effort that we'll use it so that these jobs are executed as a group jobs or bag of tasks. We generally call it BOT jobs or group of jobs. So when we talk about this throughput is meant for the bag of tasks and group of jobs, where try to reduce the execution time of all these jobs together, so that you try to reduce the turnaround time as much as possible, TATP call, right? So reduce the turnaround time for a group of jobs and group of tasks, then become the high throughput computing model, and reduce the computation time as much as possible for a single task, then become a high performance computing model. Okay, so this HPC and HTC are widely used even when you talk about the computing infrastructures like a clusters, right? So cluster is a group of systems where they're interconnected together to perform a specific task. Okay, so in that, these things are in fact are adopted from those kind of a model, but in this case they're like a wide and vast infrastructure. And there is another model which we try to use, especially for a large data volumes, the execution models, which is called a data intensive computing model. And most of these data intensive computing models goes a programming model, which is called the MR model, which is a map reduce programming model. Okay, so in the case of map reduce programming model, so we don't move the data, but we move the logic to where the data is existing. That's what when you talk about this Hadoop file system and other kind of a thing, where there is a movement of a data rather than movement of logic rather than movement of a data, because the data is very large to do that. Okay, so in the data intensive computing model, we are giving equal priority to the data, or more priority to the data, so that the computation happens on the node where the data is existing by minimizing the IO latencies. Okay, so now coming to this, jumping to the cloud platform tools is for application development. In fact, when you see, there are so many application development models, like probably you could have been seen as of now. Maybe one of the tool I even also saw in the brochure. There is a Salesforce. So there was some kind of sessions have been conducted as a Salesforce on-demand CRM kind of a model. And there is a Google App Engine which is used as the web application development, where the applications of the web-related things can be directly hosted onto the Google App Engine. And not only that, there are many services which Google offers, right? So you can also use them as a services and to run your program. Like it could be like a location service, it could be the ML service, it could be the data fetching service, it could be analytical service, and the NLP service, whatnot. So many services Google also offers to convert your most of your requirement into the thing. Like for example, you wanted to convert speech to the text. So the speech to text is the NLP, which is provided as a service from the Google. So you can directly use them. Like a location services in the mobile, I use these location-based services where I could be able to get the place name and the latitude, longitude of the location information, right? So this is the different services which each company, in industry offers depending on the kind of services they've been doing it for their end users. And the Salesforce is one of another domain where they offer this customer relationship management kind of an application development using the Salesforce platform, right? So it's basically you need not to do any upfront cost and upfront software packages purchased. So those things probably one can do it in using the Salesforce kind of a platform. Similarly, there is another platform which we are going to discuss today, which is called Aneka, which is a general purpose .NET based computing model, which is mostly used for these academic institutions to understand about the programming models and write a code and do that. Okay, that's what we that's what we'll try to do, the kind of a programming models using the Aneka. Okay, so now coming to the kind of the models which Aneka provides, it has something called high performance model, which is a thread model, high throughput model, which is called as a task model, and data intensive model, which is called the map reduce model. That means to address these three major programming models, Aneka provides three types of things. One is called as the thread model, other one is the task model, and thread model is to address the performance and the throughput task model, and for data intensive there is a map reduce model. Okay, and as it is said, like it's a .NET based computing model, it supports Windows and it also supports the Linux platform, that means Linux platforms also. Only thing is there should be a .NET environment on the Linux platforms to do that. Okay, so one can use either Windows or Linux to do these kind of platform development things. Now coming to the platform for the Aneka Cloud platform development model, which I hope the first class you had a talk from Professor Rajkumar Bhuya, who is the brain behind this Aneka platform development, and is as you are aware, he is the professor of University of Melbourne and director of Cloud Computing Laboratory, and is the CEO of Microsoft company. And based on the all these things, he has made one so it says like what is Aneka? Aneka says it is a service-oriented architecture model developed at Grid Labs, and it supports multiple programming models, and it is also have this using this like API libraries and also for doing the programming thing. As explained, it supports Windows and widely, and if at all somebody would like to use it, writing the .NET framework onto Linux platform. Okay, fine. So picture of the Aneka, if you see. So Aneka is a lightweight container hosting multiple services. It has a multiple program model supports, and it gives the SDK software development kit, and it has a environment suitable for development of clouds and .NET and Windows, which is a monoline. Okay. Now this is the right side if you see, it's a framework, the container architecture, where the ground level if you see, there can be any cloud which is coming from. It could be the public cloud like Amazon, it could be the IBM, it could be the Google, we generally call it. And there is a network, if it is not in the public, so probably it can be a private network like a private cloud kind of network. Now there is a physical machines where it can run on the physical machines, or it can also run on the virtual machines. The physical machines are the one where you can directly use your laptop, maybe any kind of workstations or desktops directly to run it. That becomes like a physical. And in the case of virtual, you can run these virtual machines as the VMs, which is running on the hardware. Okay, that's where it could be like physical or virtual. And to put a machine on that, you need to have either .NET environment or mono version of it. So that's what it becomes like infrastructure. So the bottom one is the infrastructure, which is coming from either from private cloud, public cloud, or it could be your own lab infrastructure as well. On top of this infrastructure, there is a container. So this container is divided into three major chunks. So one is called the fabric services, other than the foundation services, and goes like a programming models. Right? So when you see these fabric services, there's a hardware profiles and dynamic resource provisioning services. Then there's a foundation services which will be given, which is like a licensing services, accounting services, storage services, and other kind of membership services, which comes like a foundation. On top of the foundation, there is a models which you'll be learning in the today's class, which basically supports like three major. But there are other models also extended by another set of people from other academic institutions, where you can try to have the other models extended. Like there are some researchers who extended these kind of models even for the GPUs kind of models, right? So like for example, if someone would like to make a scheduler and run this kind of the AMI models on multiple things, so that you can able to do this kind of multiple things on the GPUs infrastructure, so that they can be scheduled not only onto the CPU, so the jobs can be scheduled onto the heterogeneous platforms like the CPUs and GPUs, so that effectively these GPUs also can be used. Right? So that's how it comes like the GPU infrastructure. Now coming to the other models, where there is a on top of it there is a which is called an application. There's a management kit. Okay, so this management kit will talk about the management studio, where one can use this configuring the entire Aneka cloud, and left side is what you see on top of like a software development kit. So this software development allows you to provide the SDK so that one can able to drive these applications for doing it. Okay, so this is the entire the infrastructure where comes from the clouds, or could be the physical machines. Our entire framework is based on divided into three major parts. One is the container, which is the middle, then application development, which is on the top, then on the bottom there is infrastructure which comes into the picture. Okay, right? Is it fine? Hope now we could able to understand about most of the things which are clear. Now coming to the thing, how do we do? In fact, people were trying to create their own infrastructure. It could be like some of the even open source tools like OpenStack, or it could be like Zen, or the VMware kind of infrastructure which is coming. And there is a provision also where one can able to do this using the thing which is also from the Amazon EC2, right? Amazon Web Services. One can able to create the resources and start using them. Right? So that's how now it comes like there is a client. When you say is a end user client, there is an SDK is provided, and there is a scheduler which runs onto the Aneka. And there could be a private cloud, it could be a public cloud which comes onto this. And one can write a program from the SDKs, like you can use this Visual Studio Development Kit to write the programs and write a program and submit to the scheduler. And the scheduler will run your infrastructure, takes infrastructure as available for you, and based on that, it runs onto the multiple infrastructure systems and do that. Okay, fine. So this is where one of the, if you want to have this Aneka installed as a physical infrastructure, you can have your own desktops connected and network and make one of the system as a master. And there is a workers, executors where will be done, and that will be explained in the next. Once we complete this, and so that how the setup and other things will take care of it, you will turn to know. Okay, or it can go on to even the virtual infrastructure as well, where a server can be used to create a multiple virtual machines depending on your requirement, and each worker can be installed on the virtual machine, and one of the system can be used as the master, and so that this master and worker can coordinate together for the execution of the infrastructure. Okay, this is what it talks about. So when you see here, so it is there is a master node which is we call like a controlling node, and there is a executor node. In fact, for demo purpose, what we do is we'll combine both master and worker node together. Okay, because difficult now to show like the entire infrastructure. So we'll make one master, and that master itself will configure it as like an executor node, so that the execution happens onto the same system. Fine. So now easy to deploy, and the nodes can join our do Java management is here, and application development becomes easier. Okay, this is what it becomes like. So you see here. So what it happens is, this is the program deployment model where the entire Anika enterprise is done, and there is a user agent. Now there is a program task is written in this way. So once the task is written, this get submitted. So once you submit, it goes and executes onto the system. Right? This is what it becomes for the doing the part. Now coming to the setup here. So the setup, it goes like this. There is a Aneka cloud, which is composed of collection of services deployed on either onto the physical or virtual machines. It could be local area network, it could be a data center, and Aneka services are hosted on a container and managed by the Aneka daemons. So key component of Aneka platform is the management studio, which is used for managing the entire infrastructure for doing it. Okay, this will be explained by the next speaker. Now this is the setup. So the master node, which is given as the center one, which manages, and these are all the slaves of the executor node. And so you have this instruction document to show you. And this is the minimum requirement which is there for you for execution, right? So even depending on the thing, even it can also change, right? So now latest work, whichever is there, it supports. And the latest version of Aneka is right now is the 5.0, which will be explained, which how to download, how to do that. That I'll hand it over to the next speaker to do that. So okay, so the next speaker will explain about you the downloading the Aneka from the site and setting it up. After that, some of the programming documents, then after that, how do you sample programs running on the Aneka container, then followed by how do we write a program using the Visual Studio kind of environments. Okay, so just give me 2 minutes, I'll hand over the thing to the next speaker. Yeah. Next speaker is going to be taking care of like madam. She's a assistant professor working in Vasavi College of Engineering. She's her name is Radha. She's working as assistant professor, and she is working on Aneka platform for her research and other activities. And so she will explain you the setup and followed by the how these things are handled. Okay? So I'll hand over the platform to Mr. Radha.
Good morning to one and all. Now I am going to show you the how Aneka is going to install in your lab or test.
Let's find out whether they can get to see the screen.
Are you able to see my screen? Can
Yes,
anyone
ma'am.
respond?
Yes,
Thank
madam.
you. Okay. So now I'm going to show you the how to install the Aneka. Actually, what is the Aneka? Already know. Aneka is nothing but it is a application platform for the cloud computing, right? It acts as a framework for building the customized applications and deploying them on the either public or the private clouds. So now I'm going to show how it is going to have the installation in your desk or lab. First, we have to download the Aneka from the Manjira soft, and we have the latest version of the Aneka 5.0. In my PC, I have already downloaded that one. 1 minute. So I have already my downloaded Aneka, and I'm clicking this one. Just I'm going to run this. And one window will appear on the screen in order to have the installation. Just click on the next, and where you have to install, it will ask the folder, the location. And here you have to give the access for the everyone, because everyone means who uses this laptop or any computer, you can give the access for everyone. So you have to click on the everyone, then click on the next, and we have to confirm the installation process. Click on the next, then it will take the process. It will take only few minutes. Just wait. Yeah. It will ask whether you have to file this file or not. You just click on the OK. Then it will finish the installation in your lab. Just wait here for a few minutes. Just close it. Now Aneka is installed in your lab. Just go to start button and search for the Aneka or a Manjira soft. So yeah, you have to click on the Aneka Management Studio. In order to have the Aneka is having the master and the workers, right? So in order to install the master and the slaves, that means the worker, we need to go for the Aneka Management Studio, and we have to install the man. First, we are going to have the master in our PC. It will the interface will look like this. Okay, so it will ask first you to provide the different configurations files or not. So we no need to have this. Just click on the no, and this is okay. So now we have to add actually to install the master, add the master. We have master and the go work. We don't have any master here. I'm going to add here one machine. Click on the file and click on the add machine. So here you need to give the IP address of your PC or anything. So I'm giving my IP address. You have to. I already. So my IP address is this. 172. 172.31.99.63. So I need to give here 1 minute. This is 172.31.99.63. And we have to give the credentials also. So in order to have the access to anyone, we need to give the credentials. So my PC credentials are, I'm giving the credentials of my PC. Okay. Then click on the OK. So you are able to see one IP address which I have entered, right? So this is the master node. We need to make it as the master node. So we need to have the master container, right? So just right click on it. So click here, install container. One minute, it is not coming. It's not coming. I'm going to uninstall. It's not coming. I'm deleting. I'm again doing. Just click here. Add mission. Then here I'm going to give 1 minute. I'm going to give the IP address 168.135 within the credential same. Just install. Yeah, just right click on that and click the install. Here we need to have the ports because we gave the port number as a 9000. Whether the port is free or not, we didn't know. So if you get this message, the port seems to be free means just we have to click on the probe until the stop. So it should be have the port seems to be free. The message should be appear like this. Then only the port is available. Next, click on OK. Next. So here no need to confirm. Just click on the finish. It will take only few minutes. Yeah. So once you install that one, it will appear like this. The icon will appear like this. Okay. And now we need to have the master node, right? So just click and just right click on that and click on the install. You can ask whether the container will be if you are accessing via the public IP, then you have to give the public ID here. So now we are not using any public ID, right? So just click on the no. Then here we have to select the master. So we first initially we are installing the master node, right? So we have to select the master here. Okay. So we have to check this probe whether the port is available or not. Just to check it, the port seems to be free. So just click on the next. Here next. So where I am going to have it is in memory. It is next. And this is the phase where suppose you are giving to some other, the service is giving to some other person. So you need to have the charge. So you can have this window here. So per hour you can charge here. Okay. So right now we are not going to charge anything. Just click on the next. And this is default. Actually, what is this Windows means? For any backup, suppose you are giving the services to another person, so they need the any backup master. So here we can have that. So now it is not necessary. Just click on the OK. Now here in the master, we didn't have any checkboxes for the discovery services, task execution services, thread execution services, map reducing executor. Why? Because here we need to check. Why? Because means in our PC only we are going to install the master and the workers also. So for master, no need to enable this checklist. But while for the workers, we need to have this checkbox. So I'm going to give this checklist. Why? Because I'm installing in my PC both the master and the workers. So I need to have this also. Okay. Just click on that and finish. So once it finish, you can able to see here left side master container. If you click on the plus, then you are able to see your master IP address. Okay, so now the Aneka is ready in your lab. Now I'm going to demonstrate with the example. That example is the that is example Mandelbrot. Okay. You already know about this Mandelbrot, how it is going to generate. Actually, it is a physical experiment, which is called as Mandelbrot, and which is a factor experiment. This factor experiment is divided into the 25 parts. I will show you. Wait. Yeah. So this is Mandelbrot. Which is powered by the Aneka. So actually this is the physical experiment and which is based on the factor experiment. It is divided into the 25 parts. It has 5 horizontal and the 5 rows of horizontal and 5 rows of the vertical. When you submit a job to the Aneka cloud, these 25 threads are created. Because 5 into 5 is the 25, so 25 threads are created, and these threads are sent to the Aneka master called called by the workers for the execution parallelly. Okay, so in order to reduce the execution time, so just click on the just clicking on the run. Just it is connected to the Aneka, and we have to make sure that we have to give the master IP address. Okay, so what I gave here is 192.168.168 0.135. Okay. So I gave the credentials also, right? So we have to give the credential as it is. So I gave the, just click on OK and it will, yeah. So when you submit a job to the Anika Cloud, these 25 threads are created and these 25 threads sent to the Anika master and called by the workers for the execution parallelly. In our PC, we have the both master and the workers itself. So I'm giving my master ID only. Okay. So it is how the job is going to execute in parallel, okay, in order to reduce the execution time. And this is one example. I am also showing the another example, that is the convolution. Okay, so actually what is the convolution means, it is a fundamental to many common image processing operators, right? And so or we can say that that we can express to have one image. Okay. I'm taking one image like this. I'm opening. And we need to go for the settings. Okay. Whether Aneka is set or not. Here we need to give the IP address of the Aneka. That is the master. I gave that IP address is 192.168.0.135. Okay. And here we need to give the credentials. Just click OK. And here we have so many functions. In order to have the edge detections for this image, then I'm going to have this edge detection. Then it will have like this. See here, you can see this. So edge detection. And you can also take another that is slides, smooth, emboss. So all these are nothing but we can remove the noises and we can have the quality images by using these functions. I suppose I'm giving the emboss. Then it will give the like this. And it will show what is the processing time, maximum and the minimum average time also. And you can have another one also, this. So it removes the noises and it gives the quality image. Like this, we can have the examples. So so now I'm going to have the example programs. Actually, we made a platform called the Visual Studio 2019. You can also download some example for this for the code from the Mandira soft. Okay. So I have an example called the thread demo hello world. That means we are going to display the message that is the hello world. And before that, I need to show you the this. Yeah, you can able to see these Aneka program exercises. You can also download have these from the Manjira soft. In this, we are going to have the source codes like this. Already the it was taught by the sir, uh, like this, and we need to have the source codes as well as the like this. You can have the program. Okay. Just I'm import this file to the Visual Studio in order to have the output. Okay. Yeah. So this is the program. I need to print the hello world at the rate GPREC. Okay. This is the output I required. So I need to configure this XML because I need to the IP address of the master. I need to give the master IP address, right? So that I need to modify in the con XML file. We have to go to this. Yeah, here I have. Just I'm opening with the notepad. Just I'm changing the my IP address. I'm giving the master node. Okay. 192.168.0.135. Just I'm running this. Debug without debug. Yeah. You're able to see the output like hello world GRE. So executed on the desktop like this. So like this, you can have so many examples. You can download the code from the Manjira soft, which examples code. Okay. So if you have any doubts regarding this, you can ask me regarding the installation and any about the programs. Thank you. Sir, hello. Hello. Ma, can you hear me? Can you hear me? Hello? Hello?
Yes, madam, you are audible, ma'am.
Thank you. So if you have any doubts regarding any installation process and in the Visual Studio, you can ask me. So you can have the slides also. We will share this PPT, and in order to download the Anika, you can directly go for the manjirasoft.com and you can have the Anika directly there. So this is the slides, and you can also have the video installation. So for the master and the workers. For a master, if you are taking the one master and another as worker, you need to install the master in one node, and you need to install the worker in another nodes. While you are installing the workers in your node, you need to select that uh, uh, discovery expertise, what I said no here. So you have to click on that. For the master, no need to checklist that one. Okay. And this is the program what I have just executed and show you. Just displaying the hello world. Okay. And and for virtualizations, you need any references, you can go through this from the zen.org for the virtualization. Okay. And you will have references, books, and the papers from this, the websites also. Thank you. So thank you, sir. Hello. 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 Hello.
Yes, madam, you are audible. Please. You are audible, madam.
Yeah, sir, almost it is finished, sir. If you have any queries, you can ask me regarding any installation of Aneka. Hello. Sri Lakshmi, madam. Sri Lakshmi, ma'am. So if you have any doubts regarding this cloud computing and Aneka, you can ask me.
Can I once again can you repeat the execution, whether it is executed in that
Ex-
that IDE or that Anika tool?
I'm not getting you, sir.
Can you once again execute that Java program, that example?
Which that example?
That
Which
team
example,
provided, that
sir?
thing.
Hello world.
Yes, yes.
Hello world. Yeah. So this is a program for the hello world. You need to write the source code. Okay.
Okay.
And here we need to configure the in XML. Why? Because I need to give the IP address of the master node. So I didn't give any IP there as it is I kept that local host. So in place of the local host, I removed that one and I placed the my PC. That means the master IP address I gave and just run that one. Just sorry. Just click on this start without a debugging. Then the result will come like this. Sir, is it okay or anything else, sir?
Oh, that's all, madam. That's all.
So once you check this code, this code is available in the Manjira soft only. Okay. Just I showed how to run this. And link is provided to the persons they will shared by.
Okay. Okay. Thank you.
This is the main program and this is the class program. Yeah. So still anybody having any doubts regarding anything?
I request the participants to ask for any kind of the queries. Okay, if no other queries, thank you, madam.
Thank you, sir.
On behalf of Department of Computer Science and Engineering, G. Pullareddy Engineering College, Kurnool, I, Dr. C. Sridhar, Professor of CSE, convey my warm wishes to all the participants. First and foremost, I thank all the resource persons for this 1 week online faculty development program on cloud computing and its applications. Despite their busy work schedule, they have shared their valuable knowledge and expertise in the domain of cloud computing. I also thank the management, principal sir, HOD sir, Vishwanath sir, Dr. S. Jahur sir, for giving me this opportunity as chief convener for this faculty development program. I thank Dr. P. Penchal Prasad, convener, P. Sri Lakshmi, co-convener, K.V. Rameshwar Reddy, Y.R. Janardhan Reddy, B. Timma Reddy, M. Raghavendra Reddy, and other organizing members for making this event and conduct in smooth fashion without any hurdles. Participants are requested to note that FDP certificates will be issued to those who have attended the sessions and submitted the quiz. Quiz link will be shared in the go to chat box, FDP WhatsApp group, and FDP certificates will be sent to your email as mentioned in the feedback form within 10 to 15 days. I thank all the participants for their patience, listening, and attending all the sessions for the entire 6 days, despite your busy academic and work schedule. Now I request Srimati T. Swati Madam, Assistant Professor of CSC Department, to convey vote of thanks. I request Swati Madam to take over the vote of thanks.
Yeah, is it audible? Yeah.
Yes.
Good morning to all. Good morning to the participants who have attended this FDP. It's a saying that a great man whispered, feeling thankfulness and not expressing is like wrapping a present and not giving it. Today, I take the opportunity to present my gratitude in words. So it's my honor to express my gratitude on this 1 week faculty development program on cloud computing and its application. Today, I take the privilege to express my gratitude in words. First, I thank all the respected speakers of this FDP, Dr. B. Rajkumar Buyagaru, Professor, University of Melbourne, Australia, Pradeep Bhattadi Garu, Technical Lead, Bangalore, Sridhar Chitraju Garu, CTO COE Kindral, T. Gopikrishna Garu, Professor, University of Ethiopia, Dr. Raghavendra Garu, Head High Performance Computing and Drones, ISRO, and Ms. Radha Garu, who have presented and provided a very good knowledge on cloud computing and its applications. I thank all the faculty members who are organizing this FDP patron, chief patron, and HOD of CSC department, Dr. N. Kashvish Garu, who is supporting continuously in organizing this FGP. Faculty advisor, Dr. S. Zahur Ulha Garu, Professor, Department of CSC. Chief convener, Dr. C. Sridhar, Professor, Dean, Department of CSC. Convener, Dr. P. Angel Prasad Garu, Associate, Department of CSC. Co-convener, Srimati Sri Lakshmi Garu, Assistant Professor, Department of CSC, on organizing this FDP and making it a great successful. On behalf of management and staff of G. Polarity Engineering College, I take the privilege to express my oath of thanks to this FTP. I thank all the participants for attending this FTP, a 1 week FTP on cloud computing and its applications. I hope everyone takes a huge knowledge on cloud concepts. Thank you once again. Thank you, sir.
I request the participants to submit the feedback form